Okay, great. So let us start. So with the applications of this partial derivatives to do the total derivative. In the partial differentiation, right, with the help of partial differentiation, so there is a way to do the total differentiation. So first of all, what is a total differentiation? So are you aware of what is total differentiation? So this total differentiation, suppose if I have the function f of x comma y, so this is the function. Now for this function, here x is a function of, again it's a function of time, or x is a function of time and y is also a function of time. Now here actually you wanted to do the derivative with respect to time, but the function is described with x comma y, but indirectly it's a function of time alone, correct or not? So this kind of cases, so if you want to do the derivative, that is df by dt. So for this, the total derivative, we call this as the total derivative. So to find out this total derivative, what we are going to do is, so first do the total, so partial differentiation, dou f by dou x. So this is the function. So f knows only x and y, but x knows t and y knows t. So that's why when you want to do the total derivative df by dt, so you do the partial derivative with respect to x and then do the derivative dx by dt, because you know that x is a function of time, plus dou f by dou y and again do the derivative dy by dt. So this is what we call as the total differentiation with the application of the partial derivative. So this kind of case comes into picture. So when there is a complex function f of x comma y, so it's not a simple function, right? So this is a complex function. Suppose if I call z is equal to f of x comma y, so dz by dt you want, but x is a function of time and y is a function of time, but z is a function of x comma y. So this kind of cases where you need to find out the total derivative with respect to time. Got it? Understood or not? So this is the kind of cases actually. So there is a case of implicit differentiation. Suppose if I have the function f of x comma y is equal to constant. So this is the most popular function and which is the simpler function. So z is equal to f of x comma y is nothing but c, which means z is equal to c plane. So where the function is described as f of x comma y is equal to c. So this one, if you wanted to apply the derivative, the total derivative on either sides, this will be dou f by dou x into dx by dx plus dou f by dou y into dy by dx, and this side you are doing the derivative with respect to x. So the total derivative is done with respect to the same variable x. So that can also be done. Here in this case, x is a function of time, y is a function of time. You are doing derivative with respect to time now. But here, f is a function of x comma y. Now here, you are doing the derivative with respect to x itself. So the total derivative with respect to x actually you are doing. Now in this case, if you wanted to find out, this value will be 0 because the constant derivative with respect to x is 0, and this is dx by dx, it is exactly the same thing. Then dou f by dou x plus dou f by dou y into dy by dx. So here our whole intention of doing this exercise is to identify the derivative of the function dy by dx, but f is a implicit function, that is f is a function of x comma y. In such case, if you wanted to identify the derivative value is nothing but dou f by dou x divided by dou f by dou y. So this is one of the most popular equation. So for a complex function which involves both x and y powers or non-linear functions of x comma y is involved, For that function, if you wanted to identify the slope at any instant, is nothing but dy by dx is equal to minus dou f by dou x divided by dou f by dou y. So this is what we are going to do it. Clear? So for example, the stream functions in case of fluid dynamics are this kind of functions. So that kind of functions, f is nothing but a stream function. In such case, if you want to find out the direction of the fluid flow at one instant, is nothing but the slope of the function at that particular point, which can be found dy by dx is equal to minus dou f by dou x divided by dou f by dou y. Clear? So this is how actually you will be finding the derivative with the help of the total differentiation for a complex function which involves multiple variables. Clear? Yeah, so you can note down this. And the same thing you can even extend for the complex functions. Suppose I have the function w is equal to f of x minus y comma y minus z comma z minus x. So here the function is defined with the variables x minus y, y minus z and z minus x. It's not f of x comma y comma z. So this is a little bit complex function. For that, if you wanted to do that partial derivative, that is dou w by dou x, if you want to do it, so here what you can identify is f may be a function of u comma v comma p, let us say, where u is equal to x minus y, v is equal to y minus z and p is equal to z minus x. Now in this case, if you want to identify the derivative with respect to any variable, so this is dou f by dou u into dou u by dou x plus dou f by dou v into dou v by dou x plus dou f by dou p into dou p by dou x. So this is how you will be doing the partial derivative itself when there are multiple functions are involved. Got it? So this is not a total derivative. This is a partial derivative when there are multiple functions that are involved here. It's not a simple function like this. Got it? So this is how actually you will be doing the partial derivatives. So when there are multiple functions are involved. So you can note down this. So these are actually one of the two important cases of partial derivatives which we need to be discussing. Note down this. Yeah. Done? Okay. So based on this understanding, we will solve some problems. And there is one more concept, that is the homogeneous equation. Let us solve some problems based on this. Then we will go to the homogeneous equation if time permits. First, we will start with the simplest case. Given u is equal to sin x by y, sin x by y, and x is equal to e power t and y is equal to t square. Y equal to t square. Find du by dt as a function of t. Verify your result by direct substitution. And verify your result with direct substitution. Can you solve this? I asked you to find out du by dt is nothing but the total derivative of the function u, where u is a function of x comma y, so which is given by sin x by y. Anybody got it? So by direct substitution, you try to verify it. What is the answer you got? Got the answer? So here du by dt is nothing but, so dou u by dou x into dou x by dou t plus dou u by dou y into, so du by dou u by dou y into dy by dt. Now here x is equal to e power t. Then dx by dt is equal to e power t again, and dy by dt is equal to 2t. So dou u by dou x is nothing but the derivative of the sine x by y with respect to x. So derivative of sine will be cos x by y into derivative of x by y with respect to x will be 1 by y into dx, so dx by dt. So dx by dt is nothing but e power t, and then plus dou u by dou y, the same function with respect to y. So derivative of sine will be cos x by y into derivative of x by y with respect to y. So this is minus x by y square into derivative of y with respect to t. So that is into 2t. So here this one is coming as cos of x by y. If you take it out, then e power t by y plus 2t into minus of x by y square. So this is the derivative. Got it? Finally, if you want to make it everything a function of t, then you can replace it. Cos of x is nothing but e power t by t square into e power t by, so y is nothing but t square minus 2t into x is e power t divided by y square is nothing but t power 4. So this is as a function of time. Clear? Got it? So the same thing, if you want to find it out, u can be expressed as sine of x can be replaced with e power t divided by t square. So do the derivative du by dt. So derivative of sine will be cos of e power t by t square, and then d by dt of e power t by t square. Now e power t by t square, you can apply u by v formula and then substitute it. That is straightforward and simple. You are going to get this answer. Clear? Understood? Yeah. Do you have any questions? Yeah. So this is straightforward and simple. Note down one more. If x increases at the rate of 2 centimeters per second, if x increases at the rate of 2 centimeters per second, at the instant when x is equal to 3 centimeters and y is equal to 1 centimeter. At the instant x equal to 3 centimeters and y equal to 1 centimeter. At what rate must y be changing in order that at what rate y must be changing in order that the function 2xy minus 3x square y that the function 2xy minus 3x square y 2xy minus 3x square y shall be neither increasing nor decreasing. Can you solve this on your own? I hope you got the idea how to solve this. If not, tell me. Got the answer? Anybody? At least you got the idea how to solve this? Yeah. So then you can try it. So if x increases at the rate of 2 centimeters per second, at the instant x is equal to 3 centimeter and y is equal to 1 centimeter. So at one particular instant, he calculated or actually he measured the x value, y value and the dx by dt value. So these are the three important parameters, he took it out. At what rate y must be changing in order that the function 2xy minus 3x square y shall be neither increasing nor decreasing. So what he indirectly asked us is, so the function u is equal to 2xy minus 3x square y, for that find out the total derivative du by dt. And then in the calculation of du by dt, so the function value, that is du by dt itself is 0 because it shall be neither increasing nor decreasing. That means du by dt is equal to 0 in the total derivative of du by dt. And then the expansion dou u by dou x into dx by dt plus dou u by dou y into dy by dt. In that dou u by dou x actually he has given as dx by dt is given as 2 centimeters per second. So what he asked us to find out is dy by dt value. That is the only unknown out of the total derivative equation which was solved for u. Got it? So that will be a straightforward procedure. You can solve it now, I think. Anybody got the answer? Okay, so let me solve this. See this, the function u is equal to 2xy minus 3x square y. So this is the function value. Now we will find out the total derivative du by dt. Why we are finding out the total derivative is, he has given an important statement. It shall be neither increasing nor decreasing. Based on that, if you do the derivative with respect to time, then you are going to get maybe a positive value or maybe a negative value or maybe 0. If it is 0, neither increasing nor decreasing. If it is positive value, it will be an increasing function. If it is a negative value, it will be a decreasing function. Now here, once you got that information, then du by dt is nothing but dou u by dou x into dx by dt plus dou u by dou y into dy by dt. Now in this du by dt, actually he said that it is 0 because it is neither increasing nor decreasing, and then dou u by dou x is nothing but 2y minus 3x square dou u by dou x. Yeah, so this is 2y and then this is minus 6xy. Dx by dt he has given us 2 centimeters per second, so into 2 plus dou u by dou y is nothing but 2x minus 3x square into dy by dt. So, and he has given the values as this is 2 and x is equal to 3 and y is equal to 1. So if you substitute in this equation, so it will be 0 is equal to 2 into 1, so that is 2 minus 6 into 3, 18 into 1 into 2 plus 2 into 3 is 6 minus 3 into 3 square, 27 into dy by dt. So this is coming as 0 is equal to, so this is minus 32. So because minus 16 into 2 is minus 32 plus 6 minus 27 will be minus 21 into dy by dt. It implies dy by dt is equal to 32 minus 32 by 21. So this is the rate of at which the y is changing, so that the function, overall function, is neither increasing nor decreasing. It is like this. Suppose here actually there is one function. For example, just take this simple case. There is a rectangle and here x is this and y is this. Now both x and y are changing, but the product of these two are maintained constant. Then, so this area is maintained constant. Then if you are increasing x, the corresponding y will be decreasing, or if you are decreasing x, the corresponding y will be increasing, so that the product is always maintained constant here. That means if one function is increasing, another function will be decreasing, and these two together will not make any change in the function of area. Got it? So such kind of case is this. Now this is a little bit complex than this area case. Clear? Rather than area, this is a little bit complex function, 2xy minus 3x square y. But both x is changing and y is changing. So if one is increasing, other will decrease, so that this function never change. Clear? Okay. Yeah. So note down one more. Surabhi, I hope you understood, right? Yeah. Note down one more. If u is equal to f of x minus y comma y minus z comma z minus x, x minus y comma y minus z comma z minus x. Prove that dou u by dou x plus dou u by dou y plus dou u by dou z equal to 0. Can you try this now? Done? Okay, great. So anybody else? Okay. I hope I don't need to solve this. Anybody else wanted me to solve this? So that will be straightforward. So you can take x minus y as r and y minus z as t and z minus x as r or p. So you are treating or you are bringing new variables here. So this is f can be written as, so this is r comma p comma q I will call. So here r is equal to x minus y and p equal to y minus z and q is equal to z minus x. Now here this function u can be treated as f of r comma p comma q. So if you want to find out dou u by dou x is nothing but dou f by dou x dou f by dou r into dou r by dou x plus dou f by dou p into dou p by dou x plus dou f by dou q into dou q by dou f. So this is how actually you have to identify the dou u by dou x value. Here this one and this one, these values you brought in the new variables. For these variables you have to find it out. So dou r by dou x is nothing but 1. So dou r by dou x is 1 and dou p by dou x is 0 because it is independent of x, and dou q by dou x is nothing but minus 1. So correspondingly you bring in here. So this is dou f by dou r into 1 and then dou p by dou x is anyway 0. You don't need to touch this, and the last one will be dou f by dou q into minus 1. That's why I kept it minus. So this is dou u by dou x. So here dou u by dou x is coming as dou f by dou r minus dou f by dou q. Exactly in the similar manner, you find out dou u by dou y and dou u by dou z and add up all these things together, you are going to get as 0. Clear? Understood? Okay. So in this case, I'll give one important question. So that will be useful down the line also, but that is a little complex. You try doing on your own. Transform the equation dou square u by dou x square plus dou square u by dou y square equal to 0 into polar form. So down the line, especially in fluid dynamics, this polar form of the Laplace equation we are going to use rigorously at multiple locations. So try to convert this into the polar form so that you will be able to remember that equation. You don't need to remember the derivation, but you need to remember the equation definitely. Got it? And the relation is here, the polar and Cartesian relation will be, so x square plus y square equal to r square. This is 1 and theta is equal to tan inverse of y by x. So this is a relation between the polar and Cartesian form. And the other way, x is treated as r cos theta and y is treated as r sin theta. So here u is a function of x comma y. Now this needs to be transformed into u should be a function of r comma theta. Then he asked us to find out the Cartesian to polar. Got it? So with the help of partial derivatives, you try to convert this function into the polar form. Yeah. So this takes a little bit of time. You take time and then try to solve it. First you find out dou square u by dou x square alone. Okay, so this is straightforward only, but the calculation part is a little bit more. Now here the function is u of r comma theta, where r is nothing but x square plus y square, or r square is equal to x square plus y square, and so, and then theta is equal to tan inverse of y by x. Now here r comma theta is the new variables that you are bringing in. Now for this actually you need to identify dou u by dou x and dou u by dou y. Sorry, dou u by dou x and then dou square u by dou x square value. But everything on the right side should be involving only r comma theta. Now here this function, if you wanted to apply dou u by dou x, then this will be dou u by dou r into dou r by dou x. Yeah, dou r by dou x plus dou u by dou theta into dou theta by dou x. But we have got the other relation, right? So here r square is equal to x square plus y square. Then if you take the derivative partially with respect to x, then this will be 2r. R square is equal to x square plus y square. Then 2r dou r by dou x is equal to 2x. So these two will cancel. Dou r by dou x is equal to x by r, right? X by r. But you want everything in terms of r comma theta. But x is equal to r cos theta divided by r. Then these two will cancel out. Then cos theta will be left over. So dou r by dou x you can replace with cos theta. Dou u by dou r you can keep it as it is. Similarly, dou u by dou theta you can keep it as it is. And dou theta by dou x. So here theta is equal to tan inverse of y by x. Then derivative of theta. So dou theta by dou x can be replaced with dou theta by dou x is 1 by 1 plus y by x whole square. And then with respect to x, this derivative will be so minus y by x square. So this is minus y by x square plus y square. So y can be treated as minus r sin theta divided by r square. Then square will cancel out. Then so we have got two important relations. Dou r by dou x is equal to cos theta and dou theta by dou x is equal to minus sin theta by r. So we have got this relation. So this is cos theta into dou u by dou r plus dou theta by dou x is minus sin theta by r into dou u by dou theta. So this is as if like cos theta dou by dou r minus sin theta by r dou by dou theta of u. So this is equal to dou u by dou x. That means dou by dou x is nothing but in polar form cos theta dou by dou r minus sin theta by r into dou by dou theta. So if you want to do the derivative with respect to x for the polar form, this is as equivalent as that of cos theta into dou by dou r minus sin theta by r into dou by dou theta. Clear? So once you arrived at this point, now what you need to do, so you have to identify dou square u by dou x square, which is the first term of the Laplace equation. Now for this, once you want to do the derivative dou by dou x is nothing but cos theta dou by dou r minus sin theta by r into dou by dou theta. So this is nothing but dou by dou x of dou u by dou x. So dou u by dou x actually you know this one, and dou by dou x is nothing but this part, right? So this of this equation, you need to take the derivative of this entire function with this format. So dou by dou theta you need to do and dou by dou r you need to do. So this is differentiating this entire function with respect to this. So you have to do that and simplify. So that's what you are going to get as dou square u by dou x square. Exactly in the similar manner you have to do for the sine also. Then you substitute both together. Then dou square u by dou x square plus dou square u by dou y square, you are going to get it in the polar form. Clear? Now you try it. I'll give you 5 more minutes. You try on your own and then try to complete this. Okay, so let me complete it. So here dou by dou x value, we got to know that this one. So dou square u by dou x square is equal to dou by dou x times of dou u by dou x. Now dou by dou x is nothing but this part. This is cos theta dou by dou r minus sin theta by r into dou by dou theta of this entire equation cos theta dou u by dou r minus sin theta by r into dou u by dou theta. So this is the thing actually what you need to do to find out dou square u by dou x square. Now this one, so take this one. So here dou by dou r you are doing the derivative. So theta is independent anyway. So then this will be cos square theta into dou square u by dou r square. And then do the derivative of this one. So here minus cos theta into, so dou by dou r of this entire function minus sin theta by, dou by dou r of sin theta by r into dou u by dou theta. Now here, so minus cos theta into dou by dou r of sin theta by r into dou u by dou theta. Got it? I hope you understood. I have written this, right? How I have written this? Yeah. Now here, so this is how actually you can done. Then exactly in the similar manner, take minus sin theta by r. Yeah. So minus sin theta by r into dou by dou theta of cos theta into dou u by dou r. And then minus sin theta by r, minus into minus will be plus sin theta by r into dou by dou theta of sin theta by r into dou u by dou theta. So this is how actually you have to apply the product rule. Now here cos square theta into dou square u by dou r square minus cos theta into, here you need to apply uv formula because both are functions of r. So sin theta by r derivative will be sin theta by r, that is minus sin theta by r square. Yeah, minus sin theta by r square into dou u by dou theta, and then plus sin theta by r into dou square u by dou theta dou r. Right? So this is applying uv on this, and then minus sin theta by r into dou by dou theta of cos theta into dou u by dou r. So cos theta into dou square u by dou theta dou r plus dou u by dou r into derivative of cos theta will be minus sin theta. So minus sin theta into dou square u by dou u by dou r. Yeah. And then plus sin theta by r into dou by dou theta of sin theta by r into dou u by dou theta. So this is, so derivative of sin theta by r with respect to theta will be derivative of sin theta will be cos theta by r into dou u by dou theta plus sin theta by r into dou square u by dou r square. So this is how actually you are going to get it. Understood how I have done this? Right? So this is straightforward as if like it is multiplication but with the derivative. So that's why here actually there is a lot of confusion in the signs. So that's why you take these steps. Don't straight away do the derivative directly as if like it is the uv formula. So rather than that, you take the cos theta out and then put a bracket and then try to do the derivative like this. Then there is a So there are no chances of making mistakes. Otherwise, there is very high possibility, 99% of the possibility you will be making the mistakes with the signs on this. Got it? So this is the how actually you have to be doing it. Now, after the simplification, what you are going to get it is, this is cos square theta into dou square u by dou r square. And then I'll just write it. Minus 2 sin theta cos theta by r into dou square u by dou r dou theta plus sin square theta by r square into dou square u by dou theta square. Sin square theta by r into dou u by dou r plus sin square theta by r into dou u by dou r plus 2 sin theta cos theta by r square into dou u by dou theta. So this is how actually you are going to get the dou square u by dou x square value. Got it? This is theta square, I think. Yeah. Right? So this is dou square u by dou y square. If you do it, this will be sin square theta into dou square u by dou r square plus 2 sin theta cos theta by r into dou square u by dou r dou theta plus cos square theta by r square into dou square u by dou theta square, then plus cos square theta by r into dou u by dou r minus 2 sin theta cos theta by r into dou u by dou theta. So this you are going to get it exactly in the similar procedure if you do for the dou square u by dou y square. Now if we add it up these two together, this will be del square u is equal to, so these two will cancel out and these two will cancel out, and then here cos square and sin square will become 1, then dou square u by dou r square, and then here sin square plus cos square again, that is becoming 1 plus 1 by r square dou square u by dou theta square, and then next sin square cos square again becomes 1, then plus 1 by r times of dou u by dou r is equal to 0, and this is what we call as the famous relation of Laplace equation in polar form. Clear? Got it? So this is a little long, little tougher only. So possibility of making mistakes while doing the simplifications, but finally what is the result you are going to get it is dou square u by dou r square plus 1 by r square into dou square u by dou theta square plus 1 by r into dou u by dou r. This is nothing but the Laplace equation in polar form. Clear? Any questions on this? Okay, great. So this is if the functions are given with other variables or actually the functions of functions. So such kind of cases, so the partial derivatives are very much useful for us for finding out the total derivatives or the partial derivatives, whatever may be the complexity that is involved in it, right? So it seems a little longer procedure, but the procedure will be exactly straightforward and a systematic way. So no intelligence is required. So straightforward simplification methodology only. Clear? Yeah. So that's all for today. So in the next class, I'm going to deal with the homogeneous functions derivatives.